All right. Um, let's talk about probably one of the most useful tool that chemists have at their disposal, and that's this thing called the periodic table. Um, despite common misconceptions, the periodic table wasn't just a clay tablet that was discovered out in the middle of the desert somewhere, but the periodic table resulted from lots of people sharing observations about the behavior of compounds, and people early on in the history of chemistry, in the early 1800s, beginning to recognize that certain elements seem to share certain uh, similar properties. And bit by bit, people started chipping away at this and recognized that there were some sort of a pattern to the behavior of the elements. There were lots of people working on this. It ended up that the Russian scientist Dmitry Mendeleev was the first person to publish a full quote unquote periodic table. And what Mendeleev did was he just organized the elements based upon increasing atomic mass. Believe it or not, scientists in the middle of the 1800s had done enough experiments to actually be able to determine the relative masses of the atoms, of the elements. And so they were able to record atomic masses. And Mendeleev put the elements in order of atomic mass, and when he did that, he noticed that there was a pattern that the elements repeated their properties. So today, as we know, the table is made up of periods, which are sometimes called the rows. Okay, and a period is a group of elements over which the properties change. And then at the end of that period, the properties begin again. So we go, for example, from lithium through neon, and then we start again from sodium through argon and potassium through krypton, et cetera, et cetera. So the rows are called the periods, and those are the patterns of the repeating properties, and that's why this is called the periodic table of the elements, because it is based on the fact that the properties of the elements are periodic based on, in the day of Mendeleev, atomic mass. We know today that it's based upon atomic number. Again, whenever you look at a periodic table, there are two numbers in the periodic table. The whole number is the atomic number. A number that is not the whole number is the atomic mass, or sometimes called the atomic weight. Okay, good. A couple of things you need to know about the periodic table. Some of the groups have special names. This group, excluding hydrogen, is called the alkali metals. This group, next door, in column 2, is called the alkaline earth metals. So this is the alkali metals. Alkali is a word that means base or base forming. These are the alkaline earths, alkaline earth metals. Okay, the two names sound a little bit similar, but don't get them confused. Okay, another very popular column on the periodic table is this very special group of elements here, and I think we all know that those are called the noble gases. That's N-O-B-L-E, noble gases, noble as far as royalty. And the special property of the noble gases, I think we all know, is that the noble gases essentially don't react with much of anything. Matter of fact, they used to be called the inert gases, but in the past 40 years, a few of these heavier noble gases have been, under extreme conditions, been found to be able to react with things. So name was changed in the 1960s to the noble gases. Noble referring to nobility, the idea that they're fairly untouchable. Another important named column or group on the periodic table is this group right here, starting with fluorine, chlorine, bromine, iodine. We don't pay much attention tacetine because it is pretty rare. These are called the halogens. And those are the more popular named periods, or excuse me, named groups on the periodic table. Another big section of the periodic table is this section right here. These are called the transition metals. And if you notice the way the periodic table is laid out, this group of elements here, which are sometimes called the inner transitions, actually fit right here. And this group down here is only put down here in order to not make the periodic table so wide that it would be kind of inconvenient to display. So notice that from 57 to 70 drops down here, so they should fit right here. And from 69 to 102 fits right here. Okay, those are called the inner transition elements. They sometimes go by the names of the lanthanides and the actinides, first member of that sort of series. They often are called the rare earth elements. Okay, so variety of names. Not real important for you to know now. And important elements, but not ones we run into in sort of everyday chemistry. Okay, so that's a overview of the periodic table. Another important thing that the periodic table tells us that we didn't realize until the early part of the last century, early part of the 1900s, was when we discovered about the structure of the atom and that electrons were the most accessible particle in the atom, that actually the elements in the periodic table are arranged based upon number of protons. You could think about that as number of electrons. And lo and behold, elements in the same column or group have the same number of valence electrons. So in column 1, very conveniently, all of the atoms have one valence electron. Again, valence electrons are the electrons that are outermost, so they are located nearest the edges of the atom, and they have the highest energy. These are the electrons that are primarily responsible for the chemical properties. So when this whole idea of electrons was discovered and people looked at how electron arrangements corresponded to the periodic table, they discovered that elements in the same column had the same number of valence electrons, which, eureka, explained why elements in the same column have similar chemical properties. They all have a similar configuration in that they all have the same number of valence electrons. Notice I didn't say same properties, I said similar properties. So lithium and sodium both have one valence electron. Lithium and sodium have very similar properties. For example, they both react with water. They react differently, however. Lithium, much less reactive than sodium. Okay, so those inner electrons play a role, but it's the valence electrons that have the primary role in determining that. Okay, in terms of valence electrons, we tend to skip over the transition metals. We can't easily predict the number of valence electrons of the transition metals. And we'll talk about that a little bit later. But then we jump over here to the other columns. 3 valence electrons here in this column. 4, 5, 6, 7. And everybody in the noble gas column has 8 valence electrons, except for helium, which is special. It has 2 valence electrons. Again, in the column numbering system, the columns are numbered numerically, 1, 2, again, we ignore 3 through 12 for right now. And then we start with 13, 14, 15, 16, 17, and 18. Notice that the last digit in the column number corresponds to the number of valence electrons. So again, periodic table, a handy tool for helping you navigate this world of chemistry. It really simplifies chemistry because instead of us having to know something about every single element on the periodic table, if we know something about how an element with a certain number of valence electrons will behave, we know something about everybody who's a member of that column. Okay, good. So that's some basics of the periodic table, and I think we'll end this lesson there and start the next one where we use the periodic table to predict the formation of ionic compounds. And the whole idea of atoms looking to get the same number of electrons as noble gases. Noble gases are stable. Our theory is that having the same number of electrons as the noble gas makes you stable. All right,